Yes, run. Okay. Again, 10 minutes worth of notes. I'll leave that up there. All right. So, afternoon, everybody. We're going to be talking about derivatives today, and I just want to do one tie-over unit. We're moving into Unit 4, which is Chapter 3 in your textbook. It's based on derivatives. We're going to be talking about why certain derivatives are the way that they are, what are the special cases, what are some other things we have not discussed. It's just called derivatives for this unit. It's the same title as the last one. I think the last one was called rate of change. Well, now we're in derivatives. Now you've already seen how to do the shortcuts. Power rule, chain rule, quotient rule. Now we're going to talk about why certain things to work out the way that they did.
Wasn't the last chapter called derivatives?
I think it was rate of change, I think. So I think I renamed it derivatives. But now we're going to be talking about special cases. This unit is not very long. It's not. Because we've already talked about the majority of stuff we need to. There's just a few things, like why is the natural log of a times a to the x power the derivative of that exponential? Why is the derivative of e to the x e to the x? Well, that's what we're talking about in this unit. It's a lot of like theoretical stuff, but also practicing proofs. So this unit should be super easy for us because it's just reviewing your properties. It's reviewing your how to find first derivatives. But I think it's important because it teaches you why certain things work that they do. And I try to keep these separated from the last unit because this can get challenging. It can get hard to prove why something works. And again, we're not doing proofs, so just get that out of your mind. I just want to discuss today one of the main topics we talked about last week. So, no, not in here. So, but yeah, we have a couple major topics still. This unit probably will take us up through the semester test. It's not very long. It's just that there's still things we have to repeat and go over. I still want to practice, the power rule. I still want to practice the quotient rule and all that good stuff. So, what was that?
It's gonna take a month.
Yeah, not even, but I always like to just schedule that out in case we need it. If we can get it early, great. We'll just start the next unit. The next unit is technically the one I want on the next semester anyway.
So we're right on the schedule.
Yeah, we're always on the schedule. I try to keep it pretty close and pretty efficient. So
doing good.
all right. Thanks.
Do you like my hi guys?
Hey guys.
That's good. You guys
a
have
smiley face like
Very, very big smile.
yeah. It's very yeah.
If you write slower with the pen, does it make the lines big?
I push harder. Harder than
How much does
so it's
that
like-
pen cost?
That's right.
what?
How much does the pen cost?
This? $100.
$100.
The new one, like the second one, costs like 150.
That is ridiculous.
So,
It's just a pen that doesn't even have ink in it.
It's a brand.
yeah, so
You're paying for the brand, not the pen.
We're definitely paying for Apple.
I'd pay it gladly. So, all right.
How many Apple products can I buy?
I like it. He thinks the brand. I think it should be sponsored.
I'm looking at buying some new stuff. All right. So, all right.
Lord, remember I have a question for you at the end.
Okay, we'll do. All right, so let's talk about our main topic today. I want to go about 10 minutes, not even that. I've already kind of wasted enough time here. Let's just jump right into it and let's talk about our main topic. I want to talk about why a certain derivative turns out the way that it does. Whoa, that is super
That's
girthy.
thick.
All right,
That's what pressing too hard.
that.
Press it too hard.
Oh, that's why. All right, so f of x. All right, so let's talk about. Let's do like a certain trig function. Let's do like 2 sine of 4x. Let's do that. I want to discuss why does the derivative turn out the way that it does. That's what I actually want to look at. Now, just talking about the derivative of this, just doing the chain rule on this particular thing, the derivative of sine is cosine, and then you take it times the derivative of the inside, which is just 4. So this ends up being 8 cosine of 4x. Like that's what the derivative ends up being. Well, I want to discuss that. I want to show you why it works out the way that it does.
Just does.
That's what I want to discuss. Now, the big thing here is, let me bring up our graph here. Okay. All right. Actually, I wonder if I should go to Desmos. Maybe Desmos would be the... Yeah, we'll go to Desmos here. All right.
Des Moines.
Let's just do it on the iPad. It'll be easier for everyone to see what I'm doing. What?
You can see that?
Yeah.
It's just very
I'm sharing my screen with them. So, all right. Did I hit record?
No. No.
Yeah, I did.
He
Good.
did.
Whew, good work. All right, so here we go. Let's go with y equals. So y is equal to, and the function I want to do, let's go with, what do we have? 2, it was 2 sine of 4x, right?
Yep.
4x, and close that parenthesis off. Okay, done. All right, and now I'm gonna try to zoom in here so you can just, whoa. All right, there we go. All right, and let's take a screenshot of that. Perfect. Okay, so
Are you gonna bring that back to your other screen?
yeah, well, we're gonna add this thing in here. All right, so we've looked at 2 sine of 4x, and we're gonna add that in here. So let's add the 2 sine of 4x. Where's my albums at? Boom. Yeah, sorry, I was messing with Snapchat filters. I thought they're funny. So that's me and my son dinking around on Snapchat. He likes it when he looks at all the photos and stuff. All right. So anyway, all right. So here's what we have. We have the sine, the 2 sine 4x, and what we want to look at is like, how do we graph that thing? Like, what are the graphs look like? So on this particular thing, we have a positive slope, then it hits 0 right about here. It's about it's about a third of the way in, and then we're going to go to negative slope up until about 1 1/4. So that's 1.25, and this was about a third. It's 0.3. Looks like repeating, and then we hit positive slope for a while, and you guys get the idea where these are the major numbers that we're hitting. This is actually one cycle length. Now this spot right where it looks like it's hitting, right, if my iPad will work, there it is. Yeah, this is right on the dead spot. That spot right there looks like it's about 1.5. I'll just say it's 1.5. So why this is important, I want you to get a glimpse of how this works. So we're at positive slope up until about 1/3, and then negative slope until about 1.25, and then it goes back up. And this is one picture length, by the way. It's right there. So so that's what I want to look at. So let's go to our next thing, and I'm going to just start drawing this just so we can see this. So at 0.3 repeating, it hit 0. At 1 1/4, it came back to 0, and then we ended at about 1.5. So I'm just going to draw a rough scale of this. So we were at positive until it hit 1.3 at 0. Then it went negative for a while and came back to 0 at 1.25, and then it went back up again until about 1.5-ish is when I'm stopping. Okay, what I'm drawing here, this is the derivative graph. Okay, it's the derivative graph.
So
Okay.
this whole time we've been drawing derivative graphs, so we've been drawing that.
It's
No.
cosine.
Okay, so what I did earlier, this is the picture
that's cosine,
this is the
not
picture of
sine.
sine,
Yeah.
right? And what I just drew was the first derivative, right? Which you guys already even said it. This picture that I just showed you, which is the first derivative graph. Now, drawing where I have positive numbers, where I hit zeros, where I hit negative numbers for the slopes. This is cosine. This is actually proving why your derivative of sine is actually cosine. You're seeing it right here in front of you, that it actually does work out the way that it does. In fact, the numbers that are involved here are perfectly 8 cosine of 4x. It's actually the exact numbers that are involved. So if I go back to Desmos and we look at this graph, it'll represent this thing right here, this picture that I'm showing you, because that's the first derivative of this sine of 4x. So I'm going to show you that. I'm going to go into Desmos here in a second. I'll graph that 8 cosine of 4x just to show you that my sine graph, that's this thing right here I just showed you a little bit ago, its first derivative is actually this picture up to 1 cycle length. So that's I'm stopping at 1.5, if that makes any sense. Does that work out for you guys? This is all I want to show you today. Okay, so let's go to Desmos. I'm going to turn this graph off. Let's turn on y equals 8. We got to go cosine of 4x. Close the parenthesis. Whoa, let's zoom out a little bit. So
just stretch.
yeah, because the 8 stretches it a little more, so it's not quite perfectly to scale. And if I zoom in, so it is a cosine graph. You can see it up here. It's at the very top, up next to 8. It's swooping down to 0. It's coming back up, and it's stopping at this moment, which I wish I could draw on that. Actually, I can.
Screenshot it.
Yeah, let's just screenshot that. All right. And let's bring that back into, oh, I'll just draw it on it right here. This graph, like, stopped right here at 1.5. This was about 2 in this region. So at 1.5, it was hitting that perfect cycle where it was drawing that cosine graph up to about there. Okay, that's the idea. It's one of those things. Once you see this and you see the concept of why we're doing this certain thing that we did, it makes total sense on why the derivatives work the way that they do. And that's what comes down to that last unit we did in that last chapter, right? The last chapter unit test that was the last question on your test was, graph the first derivatives. This is why I had you do that. It was the lead into this unit that discusses why is the derivative of sine cosine, what is the derivative of cosine? Well, that was negative sine, right? I want to show you that. That's our note that I want to do today. This is my last bit of notes and we're done for the day. Okay, so we talked about my function. If I told you that we have cosine, the derivative of it is negative sine. I want to show you that drawing. I want to discuss it. So I'm just going to draw this freehand so you can see this. All right, so here it is. Let's draw the cosine graph, then we'll take the first derivative of it. So we can hit the exact hash marks that we need. We're going to hit 2 pi down the road. This is pi. This is pi over 2. This is 3 pi over 2. This is 1, and this is negative 1. Drawing the cosine graph. Okay, so there's cosine in, kind of in a nutshell. We have slope here is 0. That's 0 slope. This is negative slope up to pi, where it hits 0. That's 0 slope. And then it went positive up until about 2 pi, where I hit 0 again. So again, the numbers I need to have 0, pi, and 2 pi are where I hit the zeros at. And then it was negative and positive. It was negative here and it was positive for slope there between those, between the hash marks. Okay, so going to my picture, so it's negative and then positive. So let's go over to my next graph. This is my last picture of the day. So we have 3 numbers. We have 0, we have pi, and we have 2 pi. My slope was negative. It was 0 in the beginning. Then I went negative and came back to 0. Then I went positive and came back to 0. And this picture is negative sine. It's sine flipped over perfectly. So that's why it's negative sine when we actually draw the first derivatives. So yeah. So let's draw a little bit better drawing of that. There we go. All right. That was all I wanted to talk about today. It was just, why did our certain trig functions work out the way that they did? How do we use it? Okay, so your question on the Google form question, it wants you to submit, how do you find that first derivative? How do you explain it in words? Well, I would explain it in terms of draw that graph, and then you're going to draw the first derivative using its slopes at all moments. Find the zeros. Just explain words. Where would the zeros be? Where is slope positive? Would it be between 0 up to pi? Would it be from 0 to 2 pi? That type of thing. You're just going to explain it in words where you're going to hit certain numbers. Okay, you don't need to show me the picture. I want you to explain it in words as best you can and many as detailed as possible. Do the best you can on that. Today's Google question is kind of a free-for-all. It's kind of explain it the best you can. Tomorrow we're going to practice it again. We're going to look at a couple other drawings tomorrow. And then, so we might look at, I think, e to the x, and we might look at tangent, I think, tomorrow when we look at the graphs of these things. Tomorrow's Zoom is going to be super short. I'm talking like less than 15 minutes, 10 minutes-ish, and then we're done. And we're not going to have homework. The homework I'm grading is your Google questions. So you need to answer these questions, and that's what I'm grading. Do the best you can, work together if you need to. Answer your questions, do the best you can, but I am done. That's all I got today. Now, again, this is an intro day, so don't feel like, oh my gosh, I'm not very good at this. Yeah, it's the first day. I just want to see if you guys were paying attention to what I was talking about. Okay. All right. For those who are online, you guys know the drill. You guys can log off, go answer your Google question of the day. But I'm going to log off here. So,
I see a ward.
yeah. See you guys later. I will see you tomorrow, probably.